Okay, let's get started. So hope you had a good Labor Day weekend. And I had a nice one, although we were supposed to, my wife likes to go to Dragon Con. I don't know how many of you heard of Dragon Con? So she likes to go to Dragon Con in Atlanta. And we were supposed to go down there this weekend, but when we left Thursday afternoon, we broke down on the in Loudon because a rodent had eaten through our ignition wire, and fortunately, it happened in Loudon where we could be towed back to the Toyota dealership rather than, say, in Chattanooga where it would have been a lot harder. So we ended up spending the weekend here, which was still nice. We saw some movies, but she was a little disappointed that wasn't able to go down to Dragon Con. So, and I like to go hiking, so I usually take the opportunity to go hiking around Atlanta. So, but at any rate, it's all good. So hopefully you're back and refreshed. I got a quick announcement for you, which is that the ACM, which is the Association for Computing Machinery, it's our professional society in computer science, and there's a student chapter here at UT. I actually encourage you to consider joining if you haven't done so already. It's just good as far as getting to know other people in computer science. It's also just good because it's good for networking. They are offering an introduction to the Unix command line interface, something that you all are getting used to, and it's tomorrow night, September 5th in Mingal 404 at 6 p.m. and they are offering free pizza and drinks. So you can get a free dinner and also learn some good tips and additional commands for using the Unix command line. So strongly encourage you all to think about showing up because you can get dinner for free and learn some useful stuff as well. Also, I know that some of you have written some posts to Piazza. I'm not sure if they've all been answered yet. I just was able to get to my email this morning, so I will be answering them during office hours, and if they have not yet been answered. Also, I have to split my office hours today because I have to go to a meeting at 2:45. So for today, my office hours are, office hours are, come on, this was working, but not working now. Why not working now? Let's go over here. So trying a different thing. Works over here. Oh, come on. Maybe it does not because there we go. Now see if this works. Yes. Okay. So today the office hours are going to be 2 to 2:30 and 3:30 to 4:15. So I'll have to leave at 2:30. If you're there, I have to leave at 2:30 because I have a 2:45 meeting over in nuclear engineering. I'll be back by 3:30. And I'll go again until 4:15. Okay? And what we're covering today, we're covering TopCoder, we're covering command line arguments, and we are going to be covering Stringstreams along with getLine. And I am not going to repeat, for the most part, what the book said. I'm going to try to hit the highlights on command line arguments and on Stringstreams, plus give you kind of a full-blown example of how you can use Stringstreams with getLine. But I want to, first of all, start out with TopCoder, which you're going to use in the lab on starting tomorrow. So you'll be doing generally one TopCoder question a day, and just want to show you kind of what is going to be involved with that. So there's in the notes for today, Dr. Plank has an introduction to TopCoder, and I've modified that because over the years the way you obtain the TopCoder software varies. But in lab, don't worry about it now, but in lab you'll be downloading a Java applet that allows you to access problems in TopCoder, and you will see that Dr. Plank will have, or that I'll have problems. I'll say something like SRM 564 division 2 250 pointer, and what you'll do when you, it looks like I have timed out, so I'll have to, redo it. That's not bad. Looks like it's totally dead. Okay. So we'll start from scratch on it. So we'll actually go to downloads, bring it up. And it is downloading right now. Reconnect failed. Okay. So we'll log in. It looks like it's really dead. Okay. Let's just quit. Okay, start again. Log in. Wow. Okay, so you'll see this screen when you get in, and you'll go up to something called practice rooms. And in practice rooms, you'll see something called SRMs. And one thing that will be annoying, I know you can't see it all that well, but the SRM number, so here it's 564, and when you go to try to get to it, you will find that the SRM numbers aren't necessarily seemingly lining up. So you think it should be where it says 551 to 575. I'm sorry, 551 to 575. But when you look over here, you see that the SRMs are only in 427. So it turns out its indexing scheme isn't too good, and you kind of have to mouse around until you get in the vicinity. So in this case, I want it 564. That turned out to be under the 851 to 875. So I go up to 564 div 2, and I select, and now it's going to take a little while to transfer the code to me. Yesterday it took like 10 minutes. Today it was much faster. And then I go to the select one right here. Again, this is all in the notes too, and I select the 250 point problem, and it brings up a screen giving me a problem statement. And in this case, the problem statement is we're doing something with palindromes. If you're not familiar with palindromes, they read the same front to back as they do back to front. So you can see here ANA. I don't think I can make this bigger, unfortunately. So ANA reads the same forwards and backwards. AAXAA does. And they're going to go a little beyond that, and they're going to be working with also what they call full palindromes. So for example, if you have something like, let's say, AXX X A, say XXA. So that is not a real palindrome, because it doesn't quite read the same front to back as it does back to front. There's an extra X at the front. But if we collapse the X's so that they're a single X, we now get A, X, A, X, A. Whoops. A, X, It's going to take me a little while to get used to this tablet. So we have A, come on. Yeah. Let's see. Got to click here, click there. Okay. So we have A, X, A, X, A. If we collapse the X's. So that's called a full palindrome because FAUX, because it's not a palindrome in its original state, but when we collapse the sequence of X's to a single character, we get a palindrome. So in this case, we're supposed to output the fact that we have a so-called full palindrome. And then if even after collapsing we don't have a palindrome, we're supposed to return the fact that we have no palindrome. So they start with this problem statement. In fact, down here, right there, they give that definition. And if you are having trouble reading this, you can follow along in Dr. Planck's notes because he has the same thing in his notes. So he has lots of handy-dandy screenshots. So there, it's actually a little bigger. So it has the 3 possible cases and what you should return in each case, which we've just covered. And then it has a problem statement, which again he's taken a screenshot of. So you're given a class and a method that you're supposed to write. So the method is called classify it. So you're taking a string as a parameter. Right here you're returning a string. And you're classifying it as a palindrome, a full palindrome, or not even a full palindrome. And then it gives the complete method signature. You should get used to seeing the word signature. That's the complete function header for a method. It's the same thing as the function prototype. So you should get used to hearing the word method signature or function signature. It means the same thing as function prototype. So we are going to return a string. The method name is classify it, and it's taking a single parameter as a parameter, and it's saying make sure your method is public. So you have to declare it. Okay, it's not declaring it for you. If we go back down here, it's giving a whole bunch of things. I actually don't have the editor window because I do it in a separate editor window. But if you look down here, you can see you have a coding area and there's nothing. So you're actually going to have to declare the class. You're going to have to declare the method. So then they go through some examples. It's helpful to go through the examples to make sure you understand what is going on. So here, A and A is obviously a palindrome. Here is a full palindrome where when they collapse all the A's at the beginning, collapse the N, and collapse these A's, you get A and A. And let's see, they should have defaults as well. Constraints. Well, not there, so I'll go to it. So at the bottom, it also has constraints, which are constraints on what the input will be, and that's very helpful. So it says word will contain between 1 and 50 characters, so you don't have to worry about receiving an empty string, which is nice. They're saying no error checking is required. And they're saying the characters will be uppercase letters between A and Z. So you don't have to worry about anything but uppercase letters. So the constraints are nice because they tell you, generally there's no error checking required in a TopCoder problem, but the constraints kind of give you limits on things. Like if you were going to declare a vector, you'd know that you could declare it to be of size 50 because they're guaranteeing that your input will never be more than 50 characters. So looking at the constraints is useful. They also have limits on how long your program can run and how much memory your programs can take. But for the problems we'll be discussing or you'll be doing in this class, unless you write an infinite loop, you won't be going beyond the 2-second time limit. You certainly won't be using more than 64 megabytes. So generally the time and space constraints won't be an issue. Okay, so then Dr. Planck goes through some examples of working with the editor. So he starts defining the class called full palindromes. He remembers to declare the method as public, and then you have to provide the actual function definition. Remember, function declaration, in this class, when I say function declaration, I'm talking about what goes up in the class declaration right here. The function definition is where I provide the method body. So I'll say function declaration, I'm not talking about the method body, I'm just talking about where in the code we declare it, which is often a .h file. And then when we actually provide the definition or the function body, that's the function definition. And initially, he just has it return palindrome, which is obviously not always the correct answer, but he's just doing it so he can kind of get familiar with the editor, which is something you might do too. So then you see these buttons down here, save, clear, compile, test. And it's always a good idea to save before you compile and compile before you test. And the reason is it's, I believe it will compile your last saved version. So if you don't save it, it will actually compile whatever you previously saved. So you have to remember to first save, then compile, then test in that order. And if you try to test before you compile, same thing, it will use a previous executable. Now you shouldn't normally have to use find, go to, undo, and redo. Hopefully you won't have to use clear either. So at any rate, he hits save and he hits compile. And it says error, string does not name a type. String does not name a type in lines 3 and 6. And that looks pretty, so here's line 3 right here. Here's line 6 right here, or I'm sorry, here's line 6. Kind of odd because string is a valid type, it seems. Does anyone know what's wrong? Pardon? That's our next problem. Okay, good eyes, but yeah, don't worry, that's not the problem here. Very good. So TopCoder doesn't automatically include the libraries for you. You have to do that yourself. So he has not included IOStream here. Therefore, string is in fact not declared. So the first thing that he is going to do is add the whoops, come on. Okay, I guess he has not actually, there we go. He added it, but it's hard to see right here. So he put it right there. He added # include IOStream, # include stream using namespace std. He compiles it again, and now he gets the error no function named classify it. And also he has an unused parameter w, which is a little less concerning. So again, you go and you look at your code, and it's like, well, yeah, I've got classify it, but as Thomas just pointed out, there's lowercase c and there's uppercase c. So it's a bit of an issue there with the fact that C++ is case sensitive and you didn't actually provide the right name. So he goes and he actually ends up getting it to compile. And of course, when he runs it, it does just fine on the first test case. So you're able to actually run it on different test cases. So let's see here. C++. And let's go to my TopCoder. There we go. Okay, so do we have... Okay, so here we have my version of faux palindrome, but it's the more complete version. Okay, so let's see if I can get it to still do what I want it to do. There we go. Okay. So here I have the coding area, so I can save it. It saves it. And if I want to test it, it brings up this box, and now I can select any example I want from its list of examples. So remember, back in the problem statement, it had some examples. So I can select any example I want, and it gives the input, or you can actually type any string you want in there if you decide you don't like any of them, and you can try to run it. And you can see that in this case the return value was palindrome, which is the correct answer. So it says, is the correct return value yes? Okay, so you can test it to your heart's content. We're just returning right now in his program, we're just returning palindrome, so obviously it works with A and A, but if he tries it with another one, it's not going to work. So if he tried it, now mine is going to work because I have the full on thing already. But let's say I ran again the test, and in his, if he tried it on this one, it would come back with not correct because he returns palindrome. And what is this? It's a false palindrome. Okay? So, but now at least he has it to the point where he can test it out. So he actually now starts to write some code. And you can, I'll give you a moment to actually let me first talk about what he's going to do, and then I'll give you a moment to look at the code. So if you're trying to work with a palindrome, the way you verify that you have a palindrome is you work from the front and the back. So you basically have two indices that you keep, one that points to the front and one that points to the back. You compare those two characters, and if they're the same, you move to the next two characters. And if they're the same, you move to the next two characters, which in this case, they're pointing to the same character, and they're the same. And now the indices would cross. So if I was doing this with colors, we'd have one index now go here, and the other index would cross over to here. And since they've crossed over, we know that we've looked at all the characters, and we have a palindrome. Now, if we were looking at this one, the A and the A match, then we'd look at the X and the X and they match, and we'd look at this X and they match. But then we'd end up looking at this X and this A, and they don't match, and so we'd say that is not a palindrome. Okay? So basically, the algorithm for seeing whether you have a palindrome is pretty simple. And if we look at his code, he is, let's see, going to do that right. Well, he's doing it. I want to look at mine. Well, no, we'll look at his. Okay. So he is first pushing his, he's going to create a second string T. And what he is doing is something that's, he's reversing the string. So he's doing T dot pushback. So he's pushing all of his characters onto the thing, but he's getting rid of any duplicates. So what he's trying to do is collapse his X's and hit all his sequences. So what he's doing is saying for I equals 1, I less than I dot size, if he's getting a different character, he pushes it back, but if he has the same character, so if he's in the middle of a sequence, he's not pushing back. Okay? So here, he pushes back the A to get the A. Then the next character is an X and it's not equal to A, so he pushes back the X. The next character is the same as the previous character, so he doesn't push back. Then he gets to this X right here. It's the same as the previous character, so he doesn't push back. Then he comes to A, and it's not the same as the previous character, so he pushes this A. Then he gets to this X. It's not the same as A, so he pushes it. Comes to this X, it's the same as the previous character, so he doesn't push it. Comes to this A, it's different than this one, and he pushes it. So when he's done, this is W right here, and this is T. Right here we have his string T, which is the reduced one. Okay, so that's what this code here is doing. So when he's done, he has W, which is the original string, and he has T, which is the compressed or collapsed version of the string. And so now he is setting up his beginning index is I and his back index is J. So he's doing now what I was saying, which is he is going to start, and he's going to, right here, start I, and over here, he's going to start with J. And now he's going to move those indices toward each other. Okay? So while I is less than J, he's going to do his comparison. So if the two characters are not equal, we don't even have a full palindrome because the two characters didn't match. If they do match, we increment I and decrement J just like I said. And remember I said when I and J cross right here, so this was, in this case, eventually J and I cross over. So when they cross over, we know that we have finished examining the string, and that's when he terminates. So if he at any point discovers it's not a palindrome, he returns not even full. Then at the end, he says if T is equal to W, so remember he's got to check T is the reduced version of W. So if T is exactly equal to W, he has a palindrome. If T is not equal to W, he has a full palindrome. So he returns full. Okay, so you may have to think about this a little bit. I've gone through it quickly. But you can see the code's not very long. It's also not correct, by the way. Okay, so I'll just warn you. But it's not very long. The real trick comes in thinking about it. How do you solve the problem? And again, I'm going to come back to this again and again throughout the semester. The way I do it is I work things out on paper first. So I would have worked it out on paper how I would compare this string to find out that I had a palindrome. And probably you figure out you have to advance from both the front and the back. So then you have to figure out how do you do that in computer terms, advance from the front and the back. And the way you do that is you use two indices like I and j, and you write the loop that you have here. And that's what's going to take a little bit of time, is figuring out how you write these loops. That's the problem solving. We're trying to get you to figure out how to solve problems on your own. And then you also had to figure out, how do I collapse the characters in the palindrome? So the other big thing here is collapsing the characters in the palindrome, and that involved creating a second string. So most of the work, you'll have about an hour in lab, involves trying to figure out how to solve the problem and then how to translate that into code. And the TopCoder problems don't normally require a lot of code. What they do require is thought. And the TAs will give you some hints. Generally, Dr. Plank gives you some hints. So if you look at the labs, and each TopCoder problem, many of them have a help file. So for tomorrow's lab, it's going to be this one where you're finding the so-called distance between strings. He gives you a help file where he gives you some hints. So you're not even on your own. He gives you some hints. Okay? And I'm not going to go through the entire rest of his lecture, but I am going to go through enough to show you that when he runs it, what he does next. So you can do some testing, and it's good to do testing before you submit it, but at some point you have to submit it for inspection, just like you inspect or submit your labs. And so the way you do that is when you're ready to submit, let's go back here, you hit the submit button over here on the far right. Okay, and it says you've made a change to your code since the last time you compiled. Do you want to continue with the submit? What this is actually saying is, hey, you actually forgot to compile your code. And when it tests your code, it's testing your executable. So it's saying you made a change, but you forgot to compile it. It's giving you a chance to go back and compile it, which you probably want to do. Okay, so I'll say yes. Okay, now would you like to submit your code? Yes. Okay, but I didn't successfully compile it, so I will compile it. There we go. Now I'll submit it. Like to submit your code? Yes. So now it's telling me that resubmission will result in a 10% penalty plus a time factor. So don't worry. We'll only care about if you get the problem correct. But TopCoder is a competitive arena, and they have competitions. And in the competitions, the faster you get something in, the more points you get. But of course, there's a penalty if you submit something and it's not correct. So they're just warning you that you're going to have a 10% penalty. Plus there's a time factor, meaning it won't just be 10%, it will be more. So the first time, I believe I'm given 250 points if I get it right, because it's a 250-point problem. If I mess up here, well, first of all, I won't get probably the full 250 points. And the reason is there's already a time factor. So the clock starts ticking as soon as you have downloaded the problem. And since I've been blabbering away here, you can bet I'm not getting a lot of points. Okay, because I've used a lot of time. Plus, I don't know how many times I've given this lecture before, so I've submitted this thing so many times I'm probably getting a 0 at this point. Okay, so at any rate, I say yes, I want to submit. Submission was successful. you can see I'm getting a measly 75 points because of how much time I've taken. At least it's not 0. Okay, so now where do I go to test it? So I have to go back to the main area for that. Remember, this was your first login area. And you can see that it came up with the editor, but now you have to go back to the main area. And it now has a, let's see, and let's figure out. Okay, we go to practice options, run system test. Okay, so we're going to go to practice options and we're going to run the system test, and it's going to run it against a whole bunch of things, test cases, including ones that you weren't given. And in my case, it all works because I'm using a piece of code that I wrote beforehand, and it all works, so I get the full 75 points. Not getting it. See, it's 184 out of 184 correct, but it shows you the test case, whether you succeeded, and the argument it used. Okay, so you're allowed to look at any case by double-clicking on it. So if you have an unsuccessful case, you should double-click on it, look at what the argument was, and try to figure out what went wrong. Okay, and he kind of goes through how he actually did it because he was actually coding it up when he did it. And you can see he had some failures on the code that I just showed you. So he actually clicks through on one of the examples and he looks at it. He goes through some about how, his thinking process in terms of how he solved it. I'm not going to go through that. I'm going to let you do it. But point is, you probably won't get it to work right the first time. So you have to then take a look at the test cases you missed, try to figure out what went wrong, and then fix it. So any questions about that? Yes?
You guys don't care about time or resubmission, just getting all the cases right.
That's right. We just care about getting it all right. So when you finally get it all right, you'll raise your hand. The TA will come around. They will look for the magic thing at the top that says that the status here, it's red, means something was wrong. Green means that all the test cases succeeded. And at the end of an hour, we actually want you to get on with the lab. So the TAs will go over the answer and you'll move on. And if you haven't finished it, the TAs will come by and make sure you made a good faith effort. As long as you made a good faith effort, we're happy. Okay? We just want to make sure you gave it a try. And sometimes you won't solve the problem. These are little brain twisters. Okay, so it does take some doing to try to solve them. Okay, other questions about it? Okay, so they are fun. Try not to let it stress you out. Like I said, we're not counting how many points you actually got, so don't stress out when you don't get a lot of points. He also points out that his code isn't the most elegant when he's done. The reason it's not the most elegant was he was rushing to get the most points he could. And in practice with a boss, you want your code to look pretty nice. But in TopCoder, they don't really care. They only care if it works. So speed is everything in TopCoder. And I think I made a few comments. It's good to read the comments from Dr. Plank at the bottom. Also a few comments from me because you can see there are some gotchas with TopCoder. One of the gotchas is that the default language for a problem is Java. So if you go back and you look at the editor again, you can see that it says Java, C++, C#, Visual Basic, Python. Well, generally it comes to you selected Java. So if you just start doing it, you're coding in Java. That's no good. So you got to remember to select C++. So that's one of the gotchas. Okay, and then make sure you always save and compile before you submit, and then save, compile, and submit before you test, because the test takes the previous submitted. So just make sure that you're always careful when you make a change to save it, compile it, submit it. Okay, and if one of your test cases causes the code to enter an infinite loop, it can take a long time because it's going through, in this case, 184 test cases, and it will give you 2 seconds before it will time you out. So it could take a couple minutes to get through all the test cases if you have an infinite loop. You just have to be patient. Okay? So you'll probably grind your teeth. You can't hit Control-C the way you would in your own program to get it to stop. So you just have to maybe look over your codes while that's happening, see if you can't figure out if something is wrong. Okay, we all good? Perfect. Okay, so let me drink some water. So next, let's talk about Args-C and Arg-V. And I'm not going to go through Dr. Plank's notes. He shows you some of the ins and outs of command line arguments, but I just want to hit the highlights for command line arguments. You first of all should have seen them in 102. Did you see them in 130 as well? Okay, so you're probably pretty comfortable with them by now, but I will tell you, still want to review a couple things. So first of all, in fact, I think I'll type here. So it'll probably be easier than, so actually I'll type in my own editor. Actually, yeah, why don't we do it here? Okay, so a couple things about TopCoder, or not TopCoder, still got my mind on that. So command line arguments. Okay, first of all, you use them to pass arguments to what? To main. So main, you often is a function just like any other function. You should be able to pass arguments to it. Now main has a very stylized form. It looks like this: int main, int argc, char star argv, or you may have seen it this way. Either one is fine. Okay, I don't care which way you write it. I prefer the first one. I think it makes it clear that it's an array of strings. You, by convention, use argc and argv. You don't have to use those names, but that's what all C++ programmers use, so you should get in the habit of using them. And that's a clever technique. The two arguments are a clever technique that allows you to input any number of arguments to your function. Okay, you can use that same technique if you want it in your own functions, although we don't really encourage it. So in effect, this is a variable length argument list, and the way we pass the variable length arguments is in an array, and the first argument gives us the count. Now, we pass in C-style strings, which are char stars. Don't worry about that for the time being. Just think of them as C-style strings rather than C++ style strings. So that's going to be an issue because our functions in C++ expect C++ style strings. So one issue, so I'm just going to list our issues. So issue 1 is that we get C-style strings, which I'll say char stars, rather than C++ style strings. So one issue is we have to convert. Another issue is that numbers come in as strings, not as numbers. Okay, we must convert the strings to numbers. So those are going to be our two big issues. Okay, a third issue, I'll just let you know, is that students often confuse CN with command line arguments. No, ooh, I get to disable. No, I don't want to enable dictation. I was hoping to disable. Okay, so I'll just let you know, a lot of times there's confusion. You can't read command line arguments with CN. Okay, so we'll just say that. You cannot read command line arguments with CN. Okay, conversely, well, actually, conversely would have been the same thing. So command line arguments come in argv. Okay, command line arguments follow the command on the command line, hence the word command line arguments. If you hit return, so if I say my thing is checkerboard, and I hit return, well, now I'm entering, anything I enter at this point is a standard input from standard in on the console and will be read with CN. So this is read, these are words read by CN because they're on a separate line. So as soon as you hit return for your command, anything you enter after that is console input. Okay? And that is being read by CN. So anything up here, those are command line arguments. Anything on the next line is console input and is read by CN. Okay? Believe me, it's confusing at the beginning, so you just have to kind of get used to it. Okay? Now, any questions about that? The solution to A is generally pretty easy. Okay? So first of all, we can simply declare a string variable. So let's say one of our arguments was width. We can simply say string width equals, and let's say it was the second command line argument. If we just say string width equals argv2, C++ will convert the C style string to a C++ string. So this declaration and initialization converts the C style string to a C++ style string. Okay? So that's a very simple way to convert it to a C++ style string. Or you might have a function, let's say int initialize, and it takes a string width. If you were to call initialize with argv2, that would work too. C++ would automatically convert the char star to a C++ string. So you can pass a C-style string to a parameter that expects a C++ string, and C++ will do the conversion. So A is pretty easy to finesse. Okay, B's not so easy. Okay, the easy thing to do, there are a couple functions, A to I, which stands for ASCII to integer, and there's also A to F, which stands for ASCII to float. Okay, so you can type int width equals A to I argv2, and if it can convert argv2 to a number, to an integer, it will, and it will return an integer. So A to I takes a string, okay, takes a C-style string, and returns an integer if possible. And same thing, takes a C-style, A to F takes a C-style string and returns a float in point number if possible. If they fail, they return 0. If these functions fail, they return 0. There is a problem. Okay, so there's two problems. First of all, one, okay, problems. One, if these functions fail, they return 0. Two, they do not work on C++ strings. They only work on C-style strings. Okay, so they only work on stuff that comes out of Arg-V. The second problem is if these functions fail, they return 0. Why do you think it's a problem if they return 0 when they fail? How do we know? What if the input was 0? Okay, on many of your lab assignments, 0 is a valid input. So it comes back 0 and, well, was the input 0 or was it an invalid string that could not be converted to a number? You don't know. Okay, this is called overloading, where we're trying to use, the problem is, okay, the problem is we are trying to use the return value to denote two different things. Okay, one is the value of the integer. Two is, did the conversion succeed? Well, you can't have your cake and eat it too. If the value is 0, then the conversion succeeded, but you'll think it failed. Okay? So I'm fine in this course if you use A to I and A to F, provided you know that 0 is an invalid input. I am not fine if you try to use A to I and A to F when 0 is a valid input. There are too many ways that 0, you could say, oh, well, I could test and say if argv2 is equal to 0. Yeah? Okay, what if I input 0, 0? Oh, I'll do that too. Well, we know what I can do. I can keep adding as many zeros as I want. So your if statements are never going to suffice. Okay? Because I can always add one more 0. I can add one more 0 than you can test for. And with floating point numbers, it's even worse. 0, 0.0, 0, 0, 0.00, 0.00, 0.00. So you can't test for all the possible variations. Ergo, you've got to come up with another way to do your conversions, and that is with string streams. So another way that we encourage you to do it is with string streams, specifically iString streams. Okay? So what you can do is you can stuff it. Normally I call it buffer. You can clear the buffer first because remember with string streams you cannot reuse them until you clear them. You can stick your argument, in this case argv2, into there using string, and now it should convert it to a C++ style string. And now you can say if buffer into with, so we declared with as an int. Okay, so this tells us whether the conversion was successful. Okay, do whatever we want with. Okay, else we failed. Okay, this is the error condition. Okay, argv2 could not be converted to an integer error processing code. So this allows us to distinguish between a failure and a success. If the width was 0, then it's just fine. We go into this true clause and do whatever we want with it. Okay, so string streams are the way we handle converting strings to numbers when it's possible that the input string is 0. We also have to use these string streams whenever we have a C++ string, because A to I and A to F do not work with C++ strings. So the only time you can use A to I and A to F right now is with the argvs. And they only work if the input is not allowed to be 0. Now sometimes all you care about is actually converting the input to a string, in which case the true case, we don't want to do anything. So in that case, we're more likely to just say if not like that, and then we'll just do the error processing code. And the reason is we don't care about the true case. Do not fall into the trap. Notice I have parentheses around this and then the not. If I don't, something very pernicious happens. It's called order of operations. Okay, what it does is it actually applies the not to buffer, which is not good. Okay, you get some really weird stuff in this case. So if you want the not to apply to the operation of the read, you have to put parentheses around it because of what we call the order of operations. It's just like multiplication and addition. If I say 3 plus 5 times 8, what's the order of operations? I'm going to have you answer the question. Yes.
5 times 8.
Very good. Very good. Don't worry. I'm just making sure we're all there. So the order of operations here is that. Okay? So it's the same thing down here. If you put the not operator before buffer, it will apply to buffer. It will apply it like this. It will say if not buffer, and then it will try to do that into width, and there's some disasters happening. So don't get trapped. Okay? So, get rid of that, make sure we have it right. So if you're taking notes. Okay, so questions about converting. Here we go. Here's our code for converting. Right here. That's our code for converting a C++ string to a number. Okay, and if it was floating point, you'd just change the width to be or int to be a double. And you can reuse the buffer as long as you clear it. So I could then, if I had int and height, okay, I could do the same thing. I could clear the buffer again, then stuff argv3 in, and do the same thing for height. So I'm allowed to reuse the buffer as long as I clear it. Okay? So that's one use of string streams. And I'm going to add a fourth thing to, so I said with command line arguments that we use them to pass arguments to main. And what I want to do is add a third bugaboo, fourth bugaboo. Okay, the command line arguments start where? Index location 1. Okay, because index location 0 contains the name of the file. Okay, so the user supplied command line arguments start at index location 1. So if the user supplied the corollary, okay, if the user supplied 3 command line arguments, their argc is no, is not 2, 4. Okay, because C and C++ add one additional command line argument, which is the name of the file, which you should never use. So you start your command line arguments at 1. Okay? Yes.
A little while ago, you used the term bugaboo.
Yes.
What is that?
I guess when I grew up in the Midwest, we used to say bugaboo is an error or slight problem. You're welcome. I guess you all haven't heard bugaboo down here. Okay. Yep. So bugaboo was a small problem. So bug was a big problem. Bugaboo was a small problem. Okay. Just so that we're clear on Midwestern nuances here.
Sounds like the infant version of bug.
There we go. Infant version of bug. That's right. A small bug. A small problem. Not a big problem. Okay. Other questions about my Midwestern vocabulary? Okay. So I did a postdoc in Pittsburgh, and I had to get used to the fact that there a pizza was a pie. And I grew up in the Midwest. I grew up in Ohio, and there a Coke is pop. But where I went to graduate school, it is a soda, and down here it is a Coke. Because it doesn't matter whether it's Pepsi or ginger ale or Dr. Pepper, it's Coke. I was told the first few months I was here, because Coke is a Southern brand. Okay. You didn't know that? I was told by a couple native Knoxvillians that when I ordered, I should just say Coke, and then if it's not, well, they just say, oh, we have Pepsi, and then you just nod and say, okay. Pepsi was the bad guy down here, the intruder. I don't know if you know, Atlanta is the home base for Coke. I didn't know that till I came down here. I learned it quickly. Okay. Let's do the last thing for today, which is I have a bunch of slides on another reason that you use string streams. So down here, the third bullet point is a useful one. Come back, this is important. This third bullet point is helpful because you will be doing a lot of work this semester where you have to read lines at a time. So the issue with CN reads only one word at a time. It doesn't read a line at a time. In fact, CN doesn't know where one line ends and the second line begins. As far as CN is concerned, your input is one long stream of characters. So if you tried to read this input here in blue with CN would just see it as a single line. Okay? The new line character is like a white space character to CN. If we want to read a line, we use getLine. Okay? But if we use getLine, we suck an entire line of input into a string. And then we need to extract that input from the line. We need to break it up into the different fields. Okay? So let's say we have this input, and you'll notice it is exam scores. And there's an issue if we use CN. What is the issue if we use CN? Yes.
You don't know the amount of information you have to pull off each line.
Very good. We don't know the amount of information we have to pull off each line. In the case of Mickey Mouse, we should only be reading 2 exams. But in the case of Donald Duck and Winnie the Pooh, we should be reading 3. And there's just no way to know how many exam scores there are. In fact, I could have been crueler and allowed any number of exam scores. So in this case, the only thing we can do is to read a line at a time. But if we read a line at a time, we then need to be able to break that line into the individual fields. Like with Mickey Mouse, we must break it into 4 fields, with Donald Duck into 5. Okay, so we're reading the exam scores and we're printing their average. Okay, and as I said, the reason why CN fails, well, we always know that first name and last name is the first 2 fields, but then the remaining fields, there may be either 2 or 3. So we could try to read exam 1, exam 2, and final. Let's say the final was optional, but we immediately run into a problem with Mickey Mouse. What does CN try to read for final? Not new line. Donald. It tries to read Donald. So it goes to the next line and tries to read Donald into final, which isn't very good. Okay? So CN fails. Instead, we read a full line of input using getLine and then break the line of input using Stringstreams. So this is our second use of Stringstreams today. The first use was to convert C style strings into integers or floats. Now we'll use them to break a line into fields. Okay? And you already have seen the syntax for getLine. You give the name of the stream, which in this case is CN. If it was a file, you would give the name of a file, but we have not yet talked about files, so don't worry about that. For the time being, you would use CN. And then string S is the variable that will contain the line that is read. Okay, now string streams, you've already seen, work just like regular streams. You extract things from an input stream using the greater than operator, and you can write to an output string stream using the output operator. So they look just like a regular input or output string, like CIN or COUT. And you can also test the input string for EOF, which I will show you in a moment. So if you want to use string streams, they are different than IO streams. So you have to say include S string. So if you include IO stream, you have not included an S string. You need to include a separate library. That's S string. For input string streams, their name is iStringstream. The functions are str, that stuffs a string into it. Clear is generally called after you have used it once. So the first time you use a string stream, you don't need to clear it. But thereafter, if you want to reuse it, you must clear it before you call str. And a lot of students forget to do that. Okay, so if you reuse a string stream, first make sure you call clear. So here again is our average exam problem. And I am using an array that can store 3 exams. And you can see I have declared my iStringstream. So again, while I may have multiple lines of input, I choose to solve the simple problem first, just like I tell you to do in lab. So before I worry about multiple lines of input, I'm going to solve the problem for a single line of input. So I get my single line of input, stuff that line into the buffer using string, and I always know that the first two fields are the first name and the last name. So I immediately read the first name and last name from my string stream. Now I do not know how many exams I have. Remember I said you could check for EOF in a string stream just like you can check for EOF with CN. So I can just write while, and as long as the read succeeds, it will read a integer into the appropriate entry in the array. And notice I'm careful to increment the count variable. So it's always reading into an empty entry in the array. And I am assuming that they are integers so that I'm not checking for any error conditions. So this while loop will finish up when I have exhausted all of the numbers. When I've exhausted all of the numbers in that line, the read will fail. It will return false because I've reached end of file. I know it's end of line. So you can think of it as, in this case, end of line. But at any rate, it returns false. We come out of our loop. We calculate our average. Okay? And notice that both sum and count, nope, sum is a double. So in fact, it will produce a floating point result. Now that I've solved the single line case, I solved the multi-line case. So now I am reading multiple lines, so I have a while statement, while get line CN, so that gets a line at a time. I need to remember to reset sum and count to 0 because I'm processing a new student each time. Also, because I'll be reusing the buffer, I need to clear it before I stuff my line in. And the remainder of the program is exactly like the single line case. So that's why I say make the simple stuff work first, because notice I didn't have to change anything, any of my code for the single line case. I just added some additional code to handle the multi-line case. So that's why I'm a big fan of incremental development. Okay? On Thursday, we'll very quickly cover, actually we won't. So I just want to point out you have challenge activities that are due for today. All the challenge activities in 16.4. You will get to do some work with output string streams in those challenge activities. So make sure you do them before Thursday.